Hi, this is Mr. Lesage, and this is a tutorial for the quiz from the factoring expressions lesson that's in the Math 7A course, Unit 1, Expressions and Equations. What we're looking at here is greatest common factors when we have algebraic expressions. In this first question, we have 4 students who were asked to write an expression, and they were instructed that the expression should have a greatest common factor of AB. So what questions would we need to ask in order to be able to do this? Well, we certainly should know what a common factor is. If we're not sure about that, we should go back and view the lessons videos to make sure we know. But let's look at each of the expressions the students came up with and see how close they were. In the first one, I can see a problem already because we have 16, which is a composite number. There are a number of factors that we can multiply to give us 16, 1 and 16, 2 and 8, or 4 times 4. However, the 3 is a prime number and only has factors of 1 and 3. So the numbers will have no common factors, and the variables with these numbers are an A with the 16, a B with the 3. There is no common factor, either number or variable, in these two terms. If we go to this expression, we can see that we have a composite number 18, and again another prime number 13, so there's going to be no number in common. That's good. But we see that we have a variable A that's common to both terms, we have a B that's common to both terms, and a C common to both terms. Therefore, the common factor would be A, B, C. All 3 of those variables are common. Olivia's answer. She has 2 composite numbers, 20 and 14. The 20 consists of factors 1, 2, 4, 5, 10, and 20. And 14 has 1, 2, 7, and 14. So they have a 2 in common. They also have an A in both terms and a B that's in common in both terms. But unfortunately, that's not all that's in common. There is a 2 and an A and a B. So this does not appear to be the best answer for this question. Let's look at Peyton's answer. Peyton has a composite number of 15. It has factors of 1, 3, 5, and 15. A composite number 14 with factors 1, 2, 7, and 14. None of those factors are in common. There is an A in each of the terms and a B in each of the terms. So each of these, the 15 ABC and the 14 AB, share common terms of AB. So Peyton has the best answer. Let's look at greatest common factor a different way. Here we have 2 terms in this expression, 32xy and the 18y. We want to find the greatest common factor for those 2 terms. So we have factored, found prime factors, or found all the factors, found all the factors for the expression 32xy. So 1 and 32, 2 and 16, 4 and 8 will give us 32, and then the x and the y. For 18, we have produced the list of factors that would give us 18, 1 and 18, 2 and 9, 3 and 6, and it has a variable of y. So we look for all of the shared numbers or variables with these 2 expressions, and we see there's a 1 that appears in both lists. There is a 2, but as we look through the rest of the numbers, we find no other numbers that are in both lists, so only the 1 and 2 are in common. If we look at the variables, we see an x here, no x here, so they don't have that in common. We see a y in this term and a y in this term, so they share that. So the greatest common factor is 2y. Is that the correct answer? The answer would be no. The 2 is correct, the y is correct, but the x is incorrect. We should not have included the x.